Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Appendix C, Circuit Arrangements. This appendix gives guidance about how circuits are arranged in an electrical installation. It explains how circuit current is worked out for consumer mains, submains, and final sub-circuits, how cables are chosen based on their current carrying capacity and voltage drop, how cable ratings are coordinated with protective devices, how an installation is divided into circuits to supply single items or multiple items of equipment so the installation performs as intended, and how cables are installed. All of these factors together determine how circuits are arranged so the installation meets the design, equipment selection, and installation requirements of this standard. Clause C1, Scope. This clause explains that the appendix is informative guidance rather than mandatory rules. It focuses on helping the designer understand how to decide circuit currents, how to select cables correctly, how to match cable ratings with protective devices, how to divide an installation into suitable circuits, and how cable installation affects performance. The aim is to support good design decisions so the overall installation works safely and reliably. Clause C2, Maximum Demand. This clause introduces the idea of maximum demand, which is the highest current that is expected to flow under normal operating conditions, rather than simply adding up every connected load at full rating. It recognizes that not all equipment operates at the same time or at full load. Clause C2.1, After Diversity Maximum Demand. This clause explains that circuit current must not exceed the rating of the protective device, and the protective device must not exceed the current carrying capacity of the conductors. For a single item of equipment, the circuit current is simply the load current of that equipment. When more than one item is connected, adding all loads together would be safe but overly conservative. In real installations, equipment usually does not operate all at once or at full load for long periods. Under these conditions, the expected current is estimated using diversity, and this estimated value is called the after diversity maximum demand. Clause C2.2, Calculation of maximum demand in consumer mains and submains. This clause explains that maximum demand may be determined by calculation, assessment, measurement, or limitation. The appendix then focuses on calculation methods for consumer mains and submains, providing guidance on how designers estimate realistic demand rather than worst-case totals. Clause C2.3, Domestic Installations. This clause introduces the approach used for domestic installations. It explains that loads are grouped by type, the demand for each group is assessed, and the contributions from each group are added together to determine the maximum demand for the installation or part of the installation. Clause C2.3.1, Method. This clause explains that an allocation of load is made for different types of equipment connected to consumer mains or submains in single or multiple domestic installations. Each load group contributes a calculated current, and these contributions are added together. The purpose is to arrive at a realistic maximum demand that reflects normal household usage rather than every appliance running at full power at the same time. Clause C2.3.2, Examples of Calculation. This clause introduces worked examples that show how the calculation method is applied in practice, assuming a stated supply voltage and equipment ratings. Clause C2.3.2.1, Example 1. This example explains how to determine the maximum demand of a single domestic installation supplied at single phase. Different types of loads such as lighting, socket outlets, fixed appliances, heating, and special loads are grouped and assessed using the diversity approach. The individual group demands are then added together to give the total maximum demand for the installation. Clause C 2.3.2.2, Example 2. This example explains how to determine the maximum demand of the heaviest loaded phase in a domestic installation supplied from a three-phase system. Loads are arranged across phases, and the demand on each phase is calculated. The phase carrying the highest current is identified as the heaviest loaded phase, and this value is used for design purposes. Clause C 2.3.2.3, Example 3. This example explains how to determine the maximum demand of the heaviest loaded phase for a block of multiple units supplied by a three-phase system. It shows how individual unit loads and communal services are assessed, how loads are spread across phases as evenly as practicable, and how the demands from individual units and communal services are combined to find the maximum demand on the most heavily loaded phase. Clause C 2.4, Non-domestic installations. This clause explains that non-domestic installations use a similar overall approach to domestic work, but the types of loads, operating patterns, and diversity assumptions are different. The maximum demand is determined by assessing the likely operating conditions of lighting, socket outlets, motors, heating, cooling, and specialized equipment used in commercial, industrial, and institutional environments. Clause C 2.4.1, Method. This clause explains that load is allocated to different types of equipment connected to consumer mains or submains in a non-domestic installation. The load current is calculated for each equipment load group in the installation, or in the affected part of the installation, and the individual contributions are then added together to obtain the maximum demand. The accompanying guidance clarifies how different load types are treated and how the calculations are carried out in practice. Clause C 2.4.2, Examples of calculation. This clause introduces worked examples that show how maximum demand is determined for non-domestic installations supplied by three-phase systems. The examples demonstrate how loads are grouped, how diversity is applied, how loads are shared across phases, and how the heaviest loaded phase is identified for design purposes. Clause C 2.4.2.1, Example 4. This example explains how to determine the maximum demand of the heaviest loaded phase for a multi-unit motel complex supplied by three-phase. Lighting, socket outlets, exhaust fans, cooking appliances, motors, pumps, and heating equipment are assessed according to their load groups. The loads are arranged across the three phases, each group is calculated using the appropriate demand rules, and the phase carrying the highest total current is identified as the heaviest loaded phase. Clause C 2.4.2.2, Example 5. This example explains how to determine the maximum demand of the heaviest loaded phase for a factory installation supplied by three-phase. Lighting, socket outlets, air conditioning, motors, welding equipment, water heating, and specialized machinery are assessed. The method shows how full load current, reduced load for additional machines, and duty cycle effects are taken into account. The loads are balanced across phases as far as practicable, and the maximum demand is taken from the most heavily loaded phase. Clause C 2.4.3, Alternative calculation method for commercial and light industrial applications. This clause introduces an alternative method based on energy demand rather than detailed equipment listing. It explains that this method may be used where experience and energy consumption data are available for similar occupancies. The approach converts typical energy demand per square meter into an equivalent electrical demand. Clause C 2.4.3.1, General. This clause explains that the alternative method uses typical energy demand values that depend on factors such as climate, hours of occupancy, energy management systems, and how evenly equipment is distributed. These values are used to estimate demand current for commercial and light industrial installations. Clause C 2.4.3.2, Example 6. This example explains how the alternative energy demand method is applied to an office tenancy. General lighting and power demand, along with air conditioning demand, are combined to give a total apparent power demand. This value is then converted to current using the operating voltage, providing an estimated maximum demand for the installation. Clause C 2.4.4 Alternative method using switchboard diversity. This clause explains that for switchboards conforming with the ASNZS 6143 series, maximum demand may be determined by applying a diversity factor to the sum of the circuit protective device ratings. The diversity factor depends on the number of downstream circuits and reflects the reduced likelihood of all circuits operating at full load at the same time. Clause C 2.5 Maximum demand in final subcircuits. This clause explains that maximum demand in final subcircuits is determined differently from consumer mains and submains. For a single item of equipment, the demand is based on the connected load. For multiple items of equipment, the demand may be limited by the rating of the circuit breaker protecting the subcircuit. Clause C 2.5.1 General. This clause explains that diversity may be applied in some final subcircuits where equipment does not operate continuously at full load. Examples include welding machines, domestic cooking appliances, and interlocked equipment, where operating conditions naturally limit simultaneous loading. Clause C 2.5.2 Welding machines. This clause explains how maximum demand is determined for welding machines, recognizing that welding loads are intermittent and often operate at less than continuous full load. Clause C 2.5.2.1 Definitions. This clause explains key terms used for welding machines. Rated primary current is the current marked on the equipment nameplate or derived from rated kilovolt amperes. Actual primary current is the current drawn during welding operation at a particular setting. Duty cycle is the proportion of time, expressed as a percentage, that welding current flows during a standard 1-minute period. Clause C 2.5.2.2 Arc welding machines. This clause explains that for an individual arc welding machine, the maximum demand is taken as the full rated primary current. For groups of machines, the demand is calculated by applying full load to the two largest machines, reduced percentages to the next largest machines, and a lower percentage to all remaining machines. This reflects the reduced likelihood that all welders will operate at maximum output at the same time. Clause C 2.5.2.3 Resistance welding machines. This clause explains how maximum demand is determined for resistance welding machines. For individual machines, the demand depends on whether the operation is varying or specific. Where duty cycle is known, a multiplier is applied to the actual primary current. For groups of machines, the largest machine is taken at full assessed value, with reduced values applied to the remaining machines. Clause C 2.5.3 Domestic cooking appliances. This clause explains that the maximum demand for a final subcircuit supplying domestic cooking appliances may be less than the full connected load. Assessed maximum demand values are applied based on the total connected energy rating of the appliances. Clause C 2.5.4 Interlocked equipment. This clause explains that where multiple items of equipment are connected to the same final subcircuit but are interlocked so that only a limited number can operate at one time, the maximum demand is assessed from the combination that produces the highest simultaneous load. Clause C3 Simplified protective device selection. This clause explains that simplified guidance is provided for selecting protective device ratings to suit common cable sizes and installation conditions. The intent is to assist designers and electricians with typical installations without requiring detailed calculations in every case. Clause C4 Simplified voltage drop. This clause introduces simplified methods for assessing voltage drop in cables. Clause C4.1 Background. This clause explains that voltage drop may be determined using methods from the ASNZS 3008.1 series. These methods account for cable type, conductor size, route length, operating temperature, and installation conditions. Clause C4.2 Examples. This clause explains how the simplified voltage drop method is applied. One example shows how to determine the minimum cable size needed to carry a given current over a specified route length while limiting voltage drop to a set percentage. Another example shows how to calculate the percentage voltage drop for a given cable size, current, and route length by comparing the required ampere meters with tabulated values. Clause C5. Number of points connected to circuits. This clause explains how to decide how many points may be connected to circuits so that circuits are safe, practical, and reliable in normal use. Clause C5.1. Number of circuits. This clause explains that any item of equipment with a current rating greater than 20 amps per phase must be connected to its own separate and distinct circuit. Where more than one item of equipment is to be connected to the same circuit, careful consideration is required. This includes how many points are supplied together, and what type they are, such as lighting, socket outlets, or appliances. It also includes how the equipment operates, recognizing that some loads vary during the day or by season. The expected circuit current must be suitable for the cable size and the protective device so the risk of overload is minimized. The effects of an overload must also be considered, especially where loss of supply could affect safety systems, emergency functions, medical equipment, or critical information and telecommunications services. Clause C5.2. Final subcircuits. This clause explains that guidance on the number of socket outlets, lighting points, and appliances that may be connected to a final subcircuit is provided to help designers and electricians achieve safe and workable installations. The method has been used over many editions of the standard and is suitable for typical installations, provided unusual loads are properly assessed. Clause C6. Guide to maximum number of cables installed in conduits. This clause explains how to determine how many cables may be installed in conduits or other wiring enclosures without causing damage during installation or service. Clause C6.1. General. This clause explains that the information is intended as guidance only. It helps determine how many cables and circuits may be installed in conduits and similar enclosures without exceeding physical or mechanical limits. Clause C6.2. Basis of calculations. This clause explains that the number of cables that may be installed in a circular enclosure is determined by comparing the internal cross-sectional area of the enclosure with the cross-sectional area of the cables, and then applying a space factor. The space factor allows for the way cables pack together and recognizes that cables and enclosures are circular rather than square. Different space factors are used depending on whether one cable, two cables, or three or more cables are installed together. The calculation method is demonstrated using common conduit and cable combinations. Clause C6.3. Application notes. This clause explains that the cable types and sizes used are based on standard catalogue sizes for cables and conduits commonly used in New Zealand installations. It explains that the method may also be applied to other combinations of enclosures and cable types, provided they are compatible. The method assumes that conduits are reasonably short, clear of obstructions, and have minimal bends. Where this is not the case, the number of cables should be reduced to avoid excessive pulling tension or bending stress. This clause also explains that the calculation does not take account of grouping effects on current carrying capacity, temperature rise, or voltage drop, and that derating factors from ASNZS 3008 must be considered separately when assessing circuit suitability. Clause C6.4. Tables C10 to C12. This clause explains that guidance tables are provided to show the maximum number of cables that may be installed in conduits for common cable sizes, cable types, and conduit sizes. The tables cover single core, 2 core and earth, and 4 core and earth cables under typical installation conditions, using the calculation principles already described. That brings us to the end of Appendix C. We have worked through how maximum demand is assessed for domestic and non-domestic installations, how final subcircuits are treated, how points are allocated to circuits, how many cables may be installed in conduits, and how simplified methods are used for protective device selection and voltage drop. Taken together, this guidance supports sound circuit design, helps manage loading and diversity, and ensures installations are practical, safe, and reliable throughout their service life. This brings us to the end of the full audiobook for ASNZS 3000, 2018. What you have listened to is a learning companion created to support understanding of the wiring rules through clear, spoken explanations and practical teaching language. It is designed to help apprentices, students, and working electricians connect the clauses together and see how the standard operates as a complete system in real New Zealand installations. This audiobook is not a replacement for the official published standard, and it must not be used as the authoritative document during design, installation, inspection, certification, or compliance work. The official version of ASNZS 3000 remains the only legally recognized reference and must always be consulted when making technical or legal decisions. Use this audiobook as a guide for learning, revision, and exam preparation, and as a way to build confidence in understanding the intent behind the rules. Always confirm details against the current authorized standard and any applicable New Zealand regulations. Thank you for listening, and I wish you all the best in your study, your exams, and your ongoing work in the New Zealand electrical industry.